audience and the monitors. Let me know when you're ready. Check, check, 1, 2. Mic test, 1, 2. Check, 1, 2.
Okay, let's get started. You see Eric holding the pedal high up. Aloha, everyone. Welcome back. Awesome. So welcome back to the afternoon session. And before we start, I just want to say that there's a wallet found. And here is that from Richard Kraut. And I hope you have money for lunch earlier. So please come to the staff to take your wallet back. And so this afternoon, we have two panel sessions. And let me first introduce myself. I am Tony Lee from NASA Jet Propulsion Laboratory, one of the co-chairs of the Ocean Up 19 program committees. And I will be the moderator for this first session of the afternoon before the break, which is shaping the future of ocean observing. And this session features a list of short presentations highlighting various areas of observing, from platform approaches to thematic area to integrated observing system that showcase the amazing achievements in the past decade and how this will shape the ocean observing in the coming decades. And here I want to welcome the panelists. First, Folasade Adeboyejo from EcoHub Initiative. We'll talk about citizen science. And then Dr. Toshio Suga from Tohoku University will talk about Argo. And then Dr. Emma Heslop from Goose and the JCOM Ocean Observation Coordination Group will talk about Sea Glider. And Dr. Lisa Levin from Scripps will talk about the deep ocean, and this is the third in a row that we talk about the deep ocean, important deep ocean topics. And then again, going further down, the C4 mapping topic will be discussed by Dr. Larry Mayer from University of New Hampshire. And then Professor Jesse Osabel will discuss the marine genomics. And after that, Dr. Annie Kasanoff from International Space Science Institute will talk about the sea level rise. And then Dr. Wei Dongyu from the National Marine Environmental Forecasting Center of China will talk about an integrated approach of ocean observing on a basin scale, which is the Tropical Pacific Observing System 2020, or TPOS 2020. And at the end of the presentation, we will have 10 minutes discussion. And because time is short, so we will not take questions from the open mics. We will take questions from the Slido. So please feel free to enter or vote for your questions in the Slido, and we will go from there. And without further ado, let's start with the first talk. And before I do that, I want to encourage the audience to look up the panelist bio in the Attendee Hub app that has the full bio for the speakers. So our first speaker today is Dr. Folasade Adeboyejo from EcoHub on citizen science.
Thank you very much, Tony. Thank you, Tony. Yeah, okay. This afternoon, I'll be talking about an initiative that we took in 2017 in order to create the awareness about ocean acidification on the African continent. So how do you actually develop a solution if you don't understand the bulk of it? In developing a solution, you are expected to be innovative. And innovation actually deals with you thinking out of the box. But what do you do when you don't understand the box? You need information, you need data. Understanding requires the information and data, and this was the essence of the creation of GOAN in 2012, with the goals to be able to collect data to understand the global OA conditions and the ecosystem response. And it was really a decisive decision to be able to use regional networks, which are currently 7 in numbers at the moment. But from the map, which is seen, you will see that basically data collection on the African continent is more like unavailable. So there's paucity of information on the continent. And this was what actually forged the move in 2017 when participants in previous networks were actually leveraged on, and were saddled with the commitment to be able to initiate the African network for the African continent. And Chibok, Warren, and Sam did a very beautiful job with this task because they were able to achieve two things. So they demystified the concept of ocean acidification. During my master's, even as a student, the concept was really, really bizarre and absurd to me then. But how do you not carry a local person, a community user, along? So what they did was being able to pinpoint the changes in the ocean system, the ocean health, which is changing, and link it up with the socioeconomic impact of people. So it was much more easier for people to relate with this, and they were able to have a buy-in. And with this, those that attended the workshop were able to give a commitment to this goal. In 2 months, the logo for the African network was developed, and it was also unanimously decided that there is a need for more people to be carried along on this. And with that, the 2017 World Ocean Day was actually tagged the Ocean Acidification Awareness Day on the African continent. And yes, so at the point where this decision was made, in some institutes, even a pH meter was not available. But because they bought in, they see the need for this aspect of data to be collected. They had the zeal to make a difference. They were committed to the cause and passionate about ocean health. And with a lot of awareness, we were able to collect data, just going to the ocean on the World Ocean Day, with the pH meter you have, and we were able to pull a lot of crowds to be able to join us in this cause. So we had measurements all the way from Europe down to South Africa, from Mexico to Australia. And this would have been impossible if we've not gotten the buy-in, and this is it. And all these people here made actual contribution to be able to achieve that. So one thing that was very unique was that before the event, there was only about 20 to 30% of people participating in Africa who actually bought into OA, the Ocean Acidification Network. And after the event and as to now, we have about 70% of the coastal states that are members of OA. And with all honesty, the East African Hub is actually doing a very great work as being a trailblazer, and there's 6 ongoing projects right on the continent. And WIMOSA also has bought into the program that every year during their symposium, either as a core event, as a side event, topics on OA is being discussed and the way forward on the African continent. Yeah, so listing the challenges and the way forward, I would like to summarize this with just 3 C's. Talking about commitment, coordination, and communication. You will all agree with me as a fledglings and infant needs to be nurtured. And using such a very young network to be able to participate in a global observation, there is a need for the commitment of resources and personnel to be able to do the coordination and the communication appropriately. Thank you very much, and I also like to thank all those that participated in moving the network to what it is today. Thank you.
Thank you for study. We now move on to Dr. Toshio Suga from Tohoku University on Argo.
Good afternoon. Is it mic on? Okay. Okay. Yes, this is an Argo float floating at the surface. And the name of this instrument is a profiling float. Its main job is not floating at the surface, but profiling. I hope everybody here already knows that, but in case, the profiling float measures temperature and salinity pressure profiles from a certain depth to the surface and transmit the data via satellite. This technology has been available since mid-1990s. The intersection of this technology and scientific need to answer the question, what are the ocean's roles in the climate system, is the place where Argo grew out of. Argo was designed as a network of over 3,000 profiling floats measuring temperature and salinity of the top 2,000 meters of the global ocean. This is what we have now. The global array has been maintained for 15 years. The keys of Argo's success are multinational commitment, depicted by this plot, and continued technology innovation, and innovative data management system, which makes near real-time and research quality data freely available. Argo has transformed ocean observing and been recognized as a model of an observing network. Okay, Argo just celebrated its milestone of 2 million profiles, as mentioned earlier. Okay, new technologies and new requirements have been emerging over the past decade. New instrument, new platform, and CTDs opened up the way to deep Argo, sampling down to the bottom, to close regional to global balances of heat, freshwater, and sea level. New sensors promoted the concept of biogeochemical Argo to address carbon cycle, ocean acidification, deoxygenation, marine resource management, and so on. Regional pilots are in place now. Okay, encouraged by input from the user community over the past decade, we have been developing a new design of Argo, which is a global, full-depth, multidisciplinary array of profiling floats, 4,600 floats, consisting of 2,400 core floats, 1,200 deep floats, and 1,000 biogeochemical floats. This Argo 2020 design will revolutionize research and services, particularly for polar seas, global ocean biogeochemistry, deep ocean physics. But its implementation is still at a very early phase, even not substantially funded yet, as indicated by this percent completion for each element. The Argo's new design relies on equivalency of 1 BGC or 1 deep float equal to 1 core float, which means every single BGC and deep float should make a core measurement, which is temperature salinity profiling down to 2,000 meters every 10 days. It likely will take more than a decade to realize this new design. Okay, here are major challenges to realize this new design, but they also lead to a great opportunity for us. We need 3 times of current investment, which is a great opportunity to increase end-user value through enhanced end-user engagement, new partners, and integration with other observing networks, and through stronger advocacy for integrated global ocean observing. Continued sensor platform development for efficiency is needed, which gives stronger opportunity for stronger collaboration with commercial partners and stronger linkage between research and operational communities. We need to ensure the access to the global ocean through political support for EEZ clearance and inter-network coordination, collaboration, integration. Since the system is becoming more complex, risk management calls for careful assessment and coordination and proper governance. All of these are actually the great opportunity for all of us to strengthen our capacity to build future ocean observing. Thank you.
Thank you very much, Toshio. We now move on to Emma on glider system.
Right, thank you very much. Oop, how do I go backwards? Right, so Ocean Obzo 9 was really important to the glider community. It was a recognition of the potential of gliders, the potential they could play within the global ocean observing system. But also at Ocean Obzo 9, there was a challenge to the glider community, a series of recommendations for the glider community to work on to play a role as part of the sustained observing system. And today we can say that the glider community has really achieved many of these. You can see a big difference in the number of regularly observed tracks between 2009 and 2019, and that's just one projection of the globe. If you look around on other projections, you see the same thing. So there are a great deal more than 20 plus standard lines now. There is work towards developing a single format for the glider data. And ocean gliders, the kind of the coordination mechanism for the sustained monitoring coming from gliders was set up in 2016 and was recognized as an emerging network in 2017 by the JCOM Observations Coordination Group. And so, although there have been many advances here, the sweet spot or the unique capabilities of gliders have not changed. Our capability to, the technology has advanced, and our capability to operate gliders routinely and regularly worldwide has increased significantly. And we are now focusing in terms of the ocean gliders task teams on perhaps exploiting for the benefit of the ocean observing system to fill these gaps, focusing on areas that take advantage of the glider unique capabilities, the high resolution long-term directed monitoring across a wide variety of variables, including acoustic monitoring, rapid deployment, and also ability to monitor in challenging conditions. So there are 4 task teams orientated towards tackling areas to support the global ocean observing system. One in boundary currents, obviously monitoring boundary currents. Another in storms, looking at taking observations ahead of hurricanes and tropical storms. Water transformation, looking at the biogeochemical and other influences of the transformation of water masses and ocean health and ecosystems. And backing this up are task teams on data management and best practices that really underpin our efforts in terms of creating a global community. So perhaps the most advanced of the glider networks to date is BOON, the Boundary Ocean Observing Network. There are now sort of 31, I think, sustained lines, and 29 lines that have been monitored intermittently. So this is a huge opportunity. And the vision of this task team is to have 100 lines and to play a significant role in the boundary current observing systems. The Storms network is also under development with 3 areas covered to date. And at the moment there is a major project going on with over 25 gliders, a coordination between NOAA, the US Navy, and also regional institutions in the Caribbean to create a picket fence and take observations ahead of hurricane tracks. And all the data goes forward to the coupled models for hurricane prediction, and the indication is very strongly that the strength of hurricanes can be much better predicted with these in situ measurements. So what could we do in 10 years if we did manage to coordinate to do this much in the last decade? The glider objectives or some goals and ideas to put forward are that a glider network could be at the core of an integrated boundary current monitoring system with upwards of 100 lines, really seriously helping to address the GLUE's coastal element and to connect the open ocean processes to the coast. And this also has strong linking ocean variability to resource management, the responsiveness to high intensity storms, and delivering on global biogeochemical and deep ocean observations, and also listening to the ocean. To do this, we will need, first of all, to do something and get the single data format in place. This will, I think, revolutionize our ability and other people's ability to access global glider data. Skills exchange, I think, is going to be important, working on the standards best practice and close coupling with modeling. I will leave it at that because I've run out of time, and also I would point you to the community white paper where there's a lot more background and detail on all of this. Thank you.
Thank you very much, Emma. So we move on to the next talk by Lisa Levin from Scripps on deep ocean observing.
Now about the deep ocean from 200 meters down to more than 10,000 meters. This is half the planet, and I'll be talking not only about the amazing animal life that you see here, but also the environmental conditions that shape that life and determine the health of the planet. Over the past decade, we made amazing progress with deep observing, with observations in deep water from ships, from the floats you've heard about, from moorings, cables, from gliders that you've heard about, from observatories. And we are now making forays into areas we've never seen before with submersibles, ROVs, AUVs, and even with animals. And all of these activities have led to a decade of amazing exploration and discovery. Much of this has acted to engage the youth and citizens of the world through telepresence. We now can bring views of the deep sea into our homes, often amazingly in real time. Yet the deep ocean remains severely undersampled, especially the biology. Of the records, the biological records that are in the Ocean Biogeographic Information System, only about 10% of them occur below 200 meters, and less than 1.5% of the time series stations that we have monitored occur below 200 meters. At the same time, we have a rapid rise in the need for deep ocean measurements in order to understand and conquer climate change, in order to manage our expanding resource extraction with the fishing, energy and minerals industries, in order to guide biodiversity conservation, to check the growing contamination and debris in deep water, and much, much more. I believe in order to tackle these problems, we need technology and innovation that will come from new stakeholders, as well as our existing programs. We need to engage industry and the exploration community. We can repurpose existing instruments and programs to address our needs. We can embrace policymakers and citizen scientists that you've heard about. We have made amazing progress in shallow water, and we need to send some of these skills we've honed down into deep water. And I think some of the important areas will be with molecular tools, with climate data and modeling, with acoustics, and with imaging. We have the challenge and the opportunity of addressing the confluence of climate change and direct human activities in the deep sea, and I suggest that we might be able to do this by identifying special sites, perhaps super sites, where there is a confluence of interest. And I propose the Clarion-Clipperton Zone off Mexico as one such site where there's much interest in seabed mining and climate, but also many other sectors are engaged there. And we have the opportunity to embrace the many UN organizations that help manage those sectors in this effort. I'm going to end early. I really want to close by suggesting that first, that the deep sea is going to be an important part of the future health of our planet, and that to observe the deep, we need to integrate our existing observing networks to create a network of deep networks, and we need to embrace new stakeholders. And if you would like to hear more about this, I would ask you to join us on a discussion on Thursday at 11:30, and also I'll direct you to the Deep Ocean Observing Strategy Science and Implementation Guide, which has just been released, and it is online. Thank you.
Thank you, Lisa, for the excellent timing. We move on to the next talk by Larry Mayer from University of New Hampshire on seabed mapping.
Thank you. When we think about ocean observations, we usually think about biological, chemical, or physical oceanographic phenomena, but I offer that there's another parameter that we often don't think about that's really the fundamental geospatial framework for all the other measurements we make, and that's measurements of the depth and the shape of the seafloor. In a terrestrial perspective, I'd ask you, what would it be like to try to forecast the weather without knowledge of the heights of the mountains and the depths of the valleys? Or what would a flood prediction map look like if we didn't know the local topography? I suspect we don't think about this because we often see these beautiful maps of the seafloor and we assume that we know the geospatial context for our measurements. But most of the information in these maps is derived from satellite altimetry. And while this has been a remarkable perspective, for a global scale, if we zoom in and take a look at the scale that we have for most of the ocean, we see that it is really not appropriate for the observations we make. For the range of applications that we have, research applications, engineering applications, ecosystem management, safety, national security, maritime heritage, and exploration, all that are supported by mapping. Fortunately, over the last 30 years, we've developed a technology, multi-beam sonar technology, that can provide the geospatial context at the scale we need. And while we focus on the seafloor, our sonars can also provide us observations of fish and other critters, of gas seeps, and of a range of physical oceanographic phenomena. And so we have the ability to map the seafloor and the water column at the scale we need. But the bottom line is, and David Miller mentioned this earlier, that only 15% of the world ocean has been mapped by multi-beam sonar. Also, as David discussed, to address this situation, the Nippon Foundation and JEPCO have partnered on a project called Seabed 2030 with the goal of facilitating the production of a freely available, comprehensive map of the world ocean by 2030. Well, this is clearly a very ambitious goal. We estimate that using current technology and limiting the mapping to areas greater than 200 meters, it would cost on the order of $3 billion to map the entire seafloor. Well, seemingly unimaginable sum, but to put it into context, it's the cost of a single Mars mapping mission. And while I love the idea that we map Mars, and I hope we continue to do things like that, I think we can also convince the powers that may be that we owe it to our own planet to do the same thing. Our own planet deserves to be mapped too. But we may be able to significantly reduce this cost, and that's through the use of autonomous vessels that are capable of going on long, unattended deep-sea mapping missions, combined with satellite altimetry and processing in the cloud. And these are not pie in the sky. These are all systems that are coming online right now. And so the way ahead, the Seabed 2030 community will continue to identify and compile existing data sets. We'll provide web-based applications of existing data sets so we know what has been mapped and what hasn't been mapped. We'll provide web-based applications that show planned mapping missions. And we even can, and we have provided operators and guidelines for data collection for vessels that are transiting with a multi-beam sonar on them, but don't have the operators to run the system. Seabed 2030 will also support the development of the new technologies that I've discussed. It'll work to develop international support for global mapping initiatives, and it'll work to promote regional mapping missions. And a wonderful example of that is the Atlantic Seafloor Mapping International Working Group, which is an output of the Galway Statement, which has done a wonderful job through international collaboration of mapping large portions of the North Atlantic. In terms of the community, what I would ask you to do is never assume that the appropriate mapping data exists. You have about an 85% chance that it doesn't. Turn on the multi-beam. If you have one on your ship, coordinate your transits with Seabed 2030 to let you know where data exists and where it doesn't. You can offset a track line. It's a sin, given the sparsity of data, to collect data where we already have it, and most importantly, recognize the need. This is it. This is all the data we have. And this scale doesn't do justice to how sparse it is. I can't make the pixels small enough. But if we are to empower the world to make policy decisions, to use the ocean sustainably, and to undertake scientific research that's informed by a detailed understanding of the global ocean floor, we then need to fill these gaps, because we can't manage and we can't protect what we don't know and understand. Thank you.
Thank you, Larry. Now we move on to the topic of marine genomics, to be presented by Professor Jesse Osbel from Rockefeller University.
Thank you. This morning, several participants asked about what will be different 10 years from now. Marine genomics will be very different, in particular eDNA. I could speak with you also about microbiomes, but let me focus only on environmental DNA. 10 years from now, we will look back on the time on marine biology before eDNA as an ancient time. A revolution is occurring with eDNA that's comparable to satellite oceanography or the Argo floats. The marine animals shed DNA in the water. If you swim in the water, you're shedding DNA. It comes off your skin. It comes in urine and feces through gills and other ways. The DNA lasts about 24 hours. The long strings of letters break up into short pieces, but they stay together long enough that we can make reliable taxonomic identifications for pieces of DNA that have been in the water for a day, sometimes 2 days. If the DNA broke up very quickly, then it would be the same as nets. We would need to be there to catch it. If it lasted weeks or months or a year, then everything would be everywhere because the animals move and the water moves. But somehow the eDNA is just right. The steps are very simple. First, one collects some water, a liter of water, half a liter of water, even smaller amounts may suffice. One puts that through a filter. We've even gotten good results using Melita coffee filters, but you can use regular scientific filters. You extract the DNA and then you analyze it. You can either ask the question, tell me all the species for which there is DNA in the sediment from this seawater, or you can ask a single question, a single species assay, and say, is there white shark DNA here? So it's a very simple procedure. Let me give you some examples of results. The evidence is growing week by week, even day by day, that eDNA works. It gives precise information both in space and time. On the left, you see the results from collecting water about 1 kilometer apart from 2 sides of a barrier beach in the eastern United States. You see lists of the top 10 species on the left found on the bay side, and on the right, the top 10 species for which DNA is found on the ocean side. Only one species, menhaden, occurred in both places. So if, in fact, there was really a great mixing of the DNA, again, everything would be everywhere. But in fact, it's very precise in space. It's precise in time as well, as you see on the right side of the figure, which shows the number of species for which we find DNA as the months go by. As the water warms, more species appear, so sometimes we are finding as many DNA from as many as 20 species of fishes, in this case, in the summer months, and then in the winter, the numbers go way down. And in the lower right, again, you see specific species. The summer species, the DNA of the summer species appears in the summer, of the winter species in the winter, and again, the summer species in the summer. Here are 5 challenges that we identify for this group to discuss in the next few days. And on Wednesday morning at 11:30, a group meets to discuss eDNA. The first challenge is growing the reference library. The reference library is good for temperate waters, for vertebrate species like fishes, less good for reefs, less good for marine worms and other less studied taxonomic groups. Second, the cost and time to get a result. Third, translating information about presence into information about abundance. there's good information that the number of reads indexes to abundance. Finally, at the bottom, I'll mention also integration with other techniques, standardization, integration with acoustics. The vision for the future, big opportunities, drones and robots that collect and filter the water, machines that do DNA preparation analysis in situ. There are companies trying to do this. And finally, genomic weather stations, which we should have in 10 years from now, genomic weather stations for marine life. The final slide gives some information about costs. On the left, an estimate of what it costs in the US to set up the capability. My estimate is $27,000 to set up a capability if you have none, $10,000 for supplies to get started. It costs about $50 to do a sample, so if one wanted to do 500 samples in a year, it would be $25,000. You could do 10 sites once a week. You could do 50 sites 10 times a year. This is probably 5 to 10% of the current price of what surveys cost, so we could do the surveys 10 to 20 times more densely or more frequently. Again, join us Wednesday morning. Thank you.
Thank you, Jesse. We now move on to the topic of sea level rise to be presented by Annie Kazanov from International Space Science Institute.
Oh, sorry. Okay. So good afternoon. Let me start with what we have learned about sea level during the last decade from observation. Sea level continues to rise at a mean rate of 3 centimeters per decade, but more importantly, it accelerates. And this is clearly visible on this figure that shows the global mean sea level from satellite altimetry over the last 25 years. Sea level also continues to rise non-uniformly, and this is illustrated on this map, where you can see the regional rate of sea level change. The red color corresponds to regions where the rate of sea level rise has been about 3 times faster than the global mean. We are now able to close the sea level budget by combining different observing systems, that is the satellite altimetry for sea level, but also, as illustrated here, we can estimate ocean thermal expansion with ARGO, and ocean mass increase due to land ice melt with gray space gravimetry. This corresponds to the blue and the green curve here. The red curve here is the sum of the two contributions, and you can see that it agrees very well with the observed global mean sea level from satellite altimetry. So closing the sea level budget is important because this means that we don't miss any important contribution. For example, the deep ocean contribution not sampled by ARGO. Another recent result, important result, concerned coastal sea level rise. Classical altimetry, satellite altimetry, does not inform about in the 10 kilometers to the coast. Yet there are some small-scale processes that occur only at the coast, for example, trends in winds and waves, river runoff in estuaries, or small-scale currents over shelves, that superimpose to the global mean rise and regional variability, regional trends, and which can make coastal sea level rise totally different, or not totally, but significantly different from the open ocean rise. And this is illustrated on this figure that shows the coastal sea level trend as a function of distance to the coast. The coast is on the left. This is based on dedicated reprocessing of JSON altimetry. And look only at upper right green curve. So you can see this is for a site south of Corsica in the Mediterranean Sea. And you can see that there is a smooth increase within 5 kilometers to the coast compared to what we see in the open ocean. So now, what are the new challenges for the coming decade? As reported in the document, A Decadal Strategy for Earth Observation from Space, published last year by the National Academy in the USA, the two key questions about sea level research are how much sea level will rise globally and regionally over the next decade and beyond in response to ice sheet mass loss and ocean warming, and how will sea level change along the world coastline. To answer this question, we need observation for process understanding and also to validate the climate models that simulate future changes. So now I will end with 3 slides and provide a set of requests or recommendations. So the first one is, what do we need in terms of observing system to detect acceleration, new regimes, tipping points, for process understanding, etc. So we need, of course, sustained altimetry mission to have a long and accurate global mean sea level record. But we also need sustained and improved observing system of all components, the ocean warming, ice sheet melting, etc., with Argo, core Argo, deep Argo, and GRACE type mission. What do we need in terms of observing system to estimate relative coastal sea level trends worldwide? So what we need here is a global multi-mission coastal altimetry dataset based on retracking of current or old altimetry mission. We have to use SAR altimetry on the Sentinel-3 mission and interferometric altimetry on SWOT, etc. And we also need to measure vertical land motion and have a denser tide gauge network. And my last slide is here, and this has been mentioned several times this morning. In order to study cause and impact of sea level rise along the world coastline, there is an urgent need of developing a coastal observing system along the highly populated coastline and perform a number of measurements that do not exist yet, at least with a global coverage. So I will not list because I think my time is over, and you can see temperature and salinity, coastal wind waves, river discharge, shoreline change monitoring, bathymetry, etc. So thank you, I stop here.
Thank you very much, Annie. Now move on to Wei Dong Yu, who will talk about a integrated observing system basin scale example, the TPOS 2020.
Thanks, Chair, and also thanks to all the previous speakers for the excellent introduction of different tools. So my work is very simple, to try to integrate all the powerful tools into a system to better sample the Pacific Ocean. So talking about the tropical Pacific Ocean observing system. I think it's most of you are familiar with the earlier development of a Pacific observing system dating back to the early 1980s. So this system is driven by the strong scientific interest and also the strong social concerns on the El Nino development. So the first super El Nino in record in 1982-83. So we take the international community spent about 10 years to build up a Pacific observing system with a core component as a tall Triton moored buoy array. So this is a 10 years, decade efforts. This tropical Pacific observing system is one successful story of the early Goose system. So its evolution is very much in line with the global observing system. So we say it's following the first Ocean Ops 99 meeting, we have a big bloom of the global observing system. But when you zoom into the Pacific Ocean, we say it's starting from 2011. So we see some kind of a decline of data return rate. This is mainly due to the different kinds of resources constraints. So we have a paper, we have a editorial in Nature to call for the strong support for the Pacific Ocean Observing System. So that is why we work to revise the Pacific Observing System. Now it's called TPOS 2020. So I think for TPOS 2020, the target is try to improve the prediction and try to have help the disaster reduction. So the upper panel, level panel is an ongoing observing system, and the lower panel is a newly proposed TPOS observing system. So compare with them, so you will see the new TPOS 2020 will very much emphasize the broader partnership around the basin, and also we very much emphasize the extended service. So not only the El Nino, but also we predict the monsoon and also the seamless prediction, including the weather to climate. So we try to expand to BGC to ecosystem concern and try to improve the ocean-atmosphere interaction, including the better mixed layer and flux sampling, and try to better integrate the satellite with the in situ observation. So the final goal is try to deliver the better information to a broader scope end users. So one example is development of a TPOS is you will say we are looking forward in the next decades. You will say is a full spectrum of variabilities in tropical Pacific region. For example, the El Nino. You will say it's not only the environment change, but also we capture the changes from the environmental to the ecosystem, try to better to support marine life in a big basin. In summary, the TPOS 2020 will be a more integrated system. So that is, we have a better satellite coverage to provide a better horizontal detail. We have mooring stations to have a high resolution time scales, and we have the new technology, including the Argo, including the glider, to have a better vertical structure. So it's some platforms are here. So we still have the traditional one, but we still we also have the new technology development. You already heard about the sail drone, the glider, the Argo, whatever. So this very much integrated system. I think it's I can conclude my presentation is for El Nino, this is a long-standing issue. So I have one question in mind, and also this question is for you. So can we better predict and be prepared for the next super El Nino? So super El Nino is coming from time to time. We should be better in the next decade to capture and predict and prepare for such kind of extreme disasters. Thank you.
Thank you very much, Wei Dong, and thanks to all the panelists who gave this wonderful presentation, giving a glimpse of the amazing achievements in this area in the past decade and how they're going to shape the next decade of ocean observing. So we now have about 10 minutes for Q&A for the panelists, and let's take a look at the questions from Slido, from the audience. I've been looking at a tiny screen for my phone. Could we load up the Slido questions? There we go. So I would like to, there are many questions that are worthy of continuing discussion way beyond these sessions, including the breakout sessions and even in the reception and over beer. But here what I'm going to do is that I'm going to pick up a couple of questions that are relatively cross-cutting across the different themes that are presented here. And so the first top two questions, hopefully we'll get to the third one. The first question is from Katie Hill. Should we foster a leadership program which would include organized mentoring as part of the post-Ocean Labs 19 agenda? Any panelists would like to address that question? I guess that applies to various programs as well as the integrated observing system as a whole. And then I'll read out the second questions while we think about the addressing it. The second question is from Frank. How do we engage nations in building a global system? And do we need to better define cost and benefit of ocean observing for them to engage? So now let's open the floor for the panelists to address, pick either of the two questions. Yeah. Emma, you had.
I'll make a comment about the second question.
Yeah, go ahead.
If I may. I personally think eDNA is an entrepreneurial opportunity. The public agencies around the world may subsidize it as part of the Global Ocean Observing System for very good reasons. But in addition, I think it's quite possible that globally there is something like $1 billion a year that private individuals, oil and gas companies, operators of wind farms, shipping companies, recreational fishermen, other people would pay to have the results from eDNA studies. So my guess is that there are people in this room who will become wealthy during the next 10 years from eDNA. It's not only a cost.
Yes, please, Lisa.
I would like to address the same question for the deep ocean. I think that of the 160-some countries with coastline, most of those countries have deep ocean. And for the small island developing states, for the SIDS, most of their EEZ and most of their territorial most of their waters are actually deep ocean. So one of the things we can do to engage in deep ocean observing is really to raise awareness for many countries of the world about the importance and the ecosystem services of the deep sea, and how make it clear, and in reference to an earlier question today, how totally linked the deep ocean is to what occurs in the shallow ocean and even the atmosphere, and help capacity build so that there is a willingness to learn about and invest in deep observing.
Thank you. Wei Dong, and then Toshio.
Yeah, I would like to echo it's Katie on the question of the leadership program. I think this is quite important when we're looking into the next decades. So our senior leaders, we need to make sure the knowledge, the expertise can be transferred or passed from our senior leaders to the new early career scientists to keep the momentum going forward. I think this is quite important. So we need such kind of a program to design how to make sure such kind of a knowledge transfer. Yeah, thank you.
Thank you. Toshio, and then Emma.
I'd like to touch the question about the cost and the benefit things. It's over there. Yes, the cost, we as Argo community, we have been working hard to estimating the cost with the partnership with the commercial, parties, and that is, maybe that would be our job. But the benefit is the, it's as the Billy mentioned this morning, it's we are not specialized to identify the actual benefit of our observations. So we need a stronger end-user community engagement or partnership to, actually reveal, the benefit, which we haven't realized yet. So I think that is important activity. So this conference is I hope this conference is the open the venue to those action. Yeah.
Mm-hmm. And then Emma, and then Larry,
Great.
and then
So I can speak about the benefit side and make a similar point to Toshio that I think that stretching down the value chain from observations to end users is an important component of understanding those benefits. I think we understand part of the benefits of the observations to the scientific community, and we can express that quite clearly. But in terms of other end users within society, the connection as to, where all of our observations sort of end up and down through the data centers through to the various service providers are not well tracked, and that this is an important, because it is the actual benefit to end users that is the cost benefit, and without an ability to express that, we will be short of information ourselves. And I would say that there is a session tomorrow, a breakout, looking at discussing this issue. Perhaps also to mention for Katie that I agree that I think leadership development programs are important. The Observation Coordination Group is doing a small thing in terms of putting forward a call for perhaps nations that have who are developing their observing capability to put forward somebody to the Observation Coordination Group to take on a leadership development role. But that's only, that's one small drop in the ocean. And I think we could all perhaps think within programs of what, what we could do on that front. I think sort of many small actions would make a big difference.
Thank you. Quick comment from Larry and then Falasade.
Yeah, I just wanted to comment on the second question too, with respect to the seafloor mapping issue. And in that case, we're very fortunate in that there is an international structure already with Seabed 2030 and JEPCO being a part of the IHO. There is an overarching international structure that can, at the end of the day, coordinate these efforts. I think the more critical thing in the short term will be organizing regional efforts. And Seabed 2030 does have 4 regional offices, and I think they'll start organizing regionally campaigns, actual mapping campaigns. And so it's kind of an inverse of what you're looking for in question 2. Here we have the overarching structure, and we need to build up the more local.
Falasade, last comment.
With the leadership question, I think the peer-to-peer platform is a very good one, although it's linking more on ocean acidification at the moment. But even with that, there is a challenge of pairing mentors with mentee. And I think the concept is a laudable one, which helps to develop those whose knowledge are still younger. But I think I actually placed the link in there that for those who are interested in things like this, but have not actually joined the platform, here's an opportunity for you to check it out. And if you're interested in mentoring people or the upcoming early career scientists, you could put your information available and you will be linked. Then if this is solid enough, it could actually be grown, or the concept could actually be transferred into other observation areas. And what was success with that definitely shows that success will be achieved in other aspects.
Thank you very much. Given time constraint, we have to move on. And thank you very much for the active audience engagement, as well as to the insightful comments from the panelists. And let's thank all the panelists again for the presentation in this session. Thank you. And while the panelists from the next session, the successes and opportunities are coming up, it's my great honor and pleasure to introduce the moderator for the next session, Dr. Margaret Linen, who is walking up. Dr. Linen is a distinguished oceanographer and climatologist, and she is the current director of the Scripps Institution of Oceanography and the vice chancellor of marine science at the University of California, San Diego. And she has also held a long list of leadership positions in various academic organizations, national funding agencies, and nonprofit organizations, as well as being the former president of the American Geophysical Union. And Dr. Nyland was also elected fellow of the American Association for the Advancement of Science and of the Geological Society of America. And she was also elected as a science envoy. Okay. Thank you.
I just want to make an announcement, please. Just a quick announcement. I won't save it for the end of the day. You'll all see that Slido is working for asking questions, but you will graduate to more advanced uses tomorrow. So you should start looking into it, getting to know it, because you will be able to opt in to various recommendations of the meeting that you might not see because you're in another breakout. So we're going to gather communities of like-minded people via Slido. So please engage with that tool because it will be very useful for the conference. Thank you.
Thank you, Eric. I can tell you when you're up close to it, that paddle is even more intimidating. Well, welcome everybody. I hope you enjoyed that last session on Flash Talks as much as I did. And we're going to turn to talking a bit about successes and opportunities. I want to make just a couple of comments about this because as we put this session together, we weren't really able to cover all of the successes and opportunities that lay behind us and in front of us. And I wanted to call your attention to a couple of things. I think that, as we talk about successes, not always, but frequently, we talk about the extent of the observing system, how many Argo floats we have, how many global drifters there are, how many gliders there are in our various systems. But the real success is, of course, the science that comes out of that. And I think that we have seen some remarkable things over the last 10 years. One of those that I want to remind you of was that only a few years ago, we were looking at policymakers all over the world wringing their hands about whether we were dealing with a hiatus in climate change, in warming. But all of us who were familiar with the data that was coming to us from Argo, and remember that Sarah Perkey pointed out that the upper 2,000 meters are about half of the warming, we all knew that through that entire period, the ocean was continuing to warm. There was no hiatus or interruption or flattening or whatever. And that result, to be able to come back to say that the Earth was still warming, even if the atmosphere had flattened out a little, was a very important and critically riveting success for our community with policymakers. You heard Craig this morning say, if you like your weather forecast, thank an oceanographer. And much of that is the result of the scientific result of our observing systems, especially the Global Drifter Array and the various moorings. And this, I think, too, is one of the things that we have to get more facile with in talking about our successes, not just in terms of how much hardware we have in or on the ocean, but these amazing results that are coming from it. Another piece of that, and we have heard a bit about this, is the development of new technology. The observing systems themselves are spurring innovation and creation of new sensors, new mechanisms, new platforms, and new systems. And we can see that in the sorts of things that are being talked about now that might be the successes that we'll talk about in 2029. Another piece that we haven't had much discussion about is the data systems that have been developed as a result of the incredible wealth of observation that's going on. We still have a lot to do in terms of making those systems interoperable and in providing incentives to get everyone to put their data into them. But the IOC and its data policy have really been a paragon in terms of laying out a framework to encourage all of us to get our data into the systems and to be able to use it. A lot of the slides we saw today were based on the fact that scientists all over the world can access this data, a tremendous success. And finally, we just touched a bit on capacity building, and we certainly have a long way to go there, but I think that we have invested, all of us have invested, not only in capacity building for the next generation, but ensuring that our partners in oceanography around the world have the capacity to be able to use that data. And hopefully in 2029, we'll talk about even more success with that. So that is a little introduction to some more detail that you're going to hear about today. I want to tell you that we've had one person who was on our panel, Jillian Campbell from UNEP, who had to cancel at the last minute. And I want to thank Martin Visbeck for jumping in to talk a little bit about some of the topics that she was going to cover. So we'll start with John Gunn, an oceanographer who has been interested in biological ecosystems and how to observe them. He has served in so many roles for this observing community at the Australian Institute of Marine Science, in the Marine group at CSIRO Tasmania, and now as an independent board member for IMOS, the Integrated Marine Observing System in Australia, and finally as a Goose co-chair. John. I don't have it.
Is that one down there?
The clicker?
Yeah.
No, there's a clicker.
Yeah. Okay.
Nick, can you find the clicker?
Oh,
it's a black.
So thanks, Margaret. Perhaps to continue the cultural exchange, I should start with a g'day, mate, the Australian way of greeting people. I was one of the people that, I think it was Eric talked about this morning, that left Ocean Obs in Venice excited and stimulated. I had a sort of interest in observations and monitoring of ocean biology, but I left there thinking, you know, there's a challenge been put to us that the Ocean Obs community really did want to extend from physics to biogeochemistry and biology. So what I thought I might start with is a bit of a scorecard. The Ocean Obs 19 and I presume 9 and I presume 19 came up with a calls to action, and these are they. The first one, well commented on this morning, was around fully implementing the physical and carbon observing system that had been envisaged in 99, changed or matured in 09, and then GCOS also had a comment on it. So I think my smiley faces say most of it. Aside from some concerns around sustaining the efforts that we've been able to put into the water over the last 20 years, I think hats off to the community, a very mature community now that have done the physical and carbon observations. There was also a call to commit to coordination of biogeochemical and biological ocean observations, and this call was both to the community and to governments. And I thought I'd just try, how many biologists and biogeochemists are there in the room now? So at the last meeting, we held a meeting of the biologists and they gave us a small room and we couldn't fill it. I would say that the commitment that the community and your organisations and governments have made in the time since 09 is a testament to why you're here. And so I think we've got some really, really strong capability in both of those new fields for the ocean observing system. I've got a tear there because I still have a dear wish that one day we'll have a fully operational and integrated coastal observing system. Tom Malone and many of his friends put together a very long and involved plan for coastal observations, integrated coastal observations, and in very few places in the world can we say we've met even close to their aspirations. There was a call to develop a framework, and I'll get back to that in a minute, and a few of my co-panellists are going to talk about some of that. And then there was a long list of things that we had to do more about, and they're listed there. By and large, you've heard about the innovation, you've heard about data. We'll hear about that from some of the panellists as well. In education, again, most of the people in this room will have a PhD in oceanography. I don't think we have any shortage of education, higher education in the developed world. But when I go to the General Assembly and IOC and talk about goose, there's a queue of people who come from developing nations to talk to goose about how we can help them develop their capacity and develop their own ocean observing systems. So I'm afraid we're still, in my estimation, well behind where we should be in that. The framework for ocean observations, again, an output 2 or 3 years late, I think, but an output of Ocean Obzo 9, went through a range of things, basically setting up a systematic approach to ocean observations. It managed to simplify governance of Goose, took one layer of IOC governance out of the mix. It created the idea of multidisciplinary EOVs, and we now have a series of EOVs, or in some cases they're called ECVs or EBVs, biodiversity variables. We now have 3 very, very...
I found this on the web for is a CBV.
Really? We have 3 fully functioning panels. That has brought a community of biogeochemists and biologists in train into the global ocean observing community that weren't there and weren't operating in a coordinated way before. We've got a rapidly evolving sort of data, products, services capability, and you'll hear a lot about that this week. And we've had some fantastic projects developed out of the global ocean observing system. We've heard about TPOS, we've heard about DEUCE, we've got a range of other projects in train as well. And best practice, particularly for those more mature observing systems at national and regional level, has become a way of doing business. Again, something that I don't think we could have said 10 years ago. So, in my estimation, our capability to do this stuff is like it never has been before. New technology, a capability across the world. But who cares about that? This is a word cloud of sorts, talking about the people who really care about ocean observations and who, in fact, in many ways demand products from us. The G7, G20, European Community, the Blue Charter, the Antarctic Treaty have all lined up and told the world that they believe ocean observations are critical going forward. Increased, more effective ocean observations are a critical part of the world. Many of the groups that have started to monitor this health of the ocean, this is the SDG report card from, I think, last year, not the most recent one. Call on people to provide data for their SDGs, SDG 14 and 13, oceans and climate in sequence there highlighted in the slide. The one noteworthy thing about that is that, in fact, out of those is 15 or 16 indicators. There is no data. There is not enough data, at least, to actually measure progress against the indicators that we've set. And if you look at a range of the other bodies that have highlighted the need for ocean data, they're in the same space. So we have the capability, but we're not hitting the mark, or we're not collecting the data that's required as yet. This is a quote not from an ocean observations person, but somebody from the United Nations Environment. We're just not doing enough. And we need to get together to fill the gaps, to use the data we've got, and that's got to involve partnerships between governments, companies, academics and citizens. Well, that came from the United Nations Environment Programme. This came out of the IOC, working with a number of partners. This is a new global ocean observing system, and I stress this is not the IOC Goose program strategy. This is a document that was meant to air what we think are the critical strategic goals for a global ocean observing system. The thing I'll leave you with is an awful lot of that is business as usual for ocean sciences, in particular in the system integration and delivery part. But the themes of communication, advocacy even, things that scientists don't often do very well, and then forming partnerships that are real and pervasive partnerships and finding a governance system that actually has shared roles and responsibilities to which we sign up and stick to is a really critical step going forward. Thank you.
Thank you, John. Next up, we have Melissa Iwamoto, a social scientist who focuses on how to use IUS data for the Pacific Islands to serve stakeholders, especially around the topic of hazards. And she now serves as director of the Pacific Islands Ocean Observing System at the University of Hawaii.
Thank you, Margaret. Aloha. If we believe that coastal and ocean information saves lives and protects livelihoods and resources, then how do we ensure that our data empower our users to do so? How do we know what our users need so that we can meet their requirements? And why is it that some data products are celebrated by users, even winning awards in some cases, while others seem irrelevant despite their innovations? My community white paper co-authors and I gathered our collective experiences to address these questions and more. And what resulted is a 3-step process that we hope inspires and guides others. We certainly aren't the first ones to think about this, so it's not a new idea, and we're definitely not the only ones to follow this process. We just organize the concepts in a way that make them easy to follow and easy to share. As we discuss successes, challenges, and lessons learned, we reflected on the impressive number of coastal and ocean instruments deployed across the globe over the past decade and across multiple disciplines. But punctuating our discussions was a key acknowledgement that coastal and ocean observing data do not automatically translate into benefits to society. Imagine, early this morning while it was still dark outside, and hopefully all of you were still asleep, over in Kaneohe on the other side of this island, a small boat fisherman checked his favorite wave buoy and forecast on his smartphone to determine if it was safe to go fishing. Now imagine a weather forecaster over here on this side in Honolulu, consulting a complex data processing system that integrates multiple forecasts and data from multiple buoys and stations to inform her official statewide coastal advisory for the morning. Both are using similar types of data, but there are important differences in the frequency, in the scale, and in their ability to access different sources and tools for those data. In other cases, the type of data required or the level of ocean data knowledge may vary. The contrast between these two end users reminds us that we cannot assume that a design for one stakeholder group will automatically benefit another, let alone all stakeholders. Rather, users must be included in an ongoing stakeholder-driven process to help determine what data to collect and how to best link that data or those data to the end users. Our 3-step process illustrates how to do this, but it's important to remember that how this looks in action on the ground can vary dramatically depending on your geography, your community, your mission. For example, while some stakeholders can easily access online surveys to provide input, others require much more face-to-face interaction, whether due to access issues, cultural protocols, or other reasons. One way our co-author in Vanuatu, a nation comprised of over 80 islands, connects with stakeholders is through a tiered engagement process that includes the national government, village chiefs, and the grassroots levels to learn what users need. This helps illustrate step 1 of this process, which is to tailor engagement to identify user needs. There is no one formula for how to do this. The key is the intent to be stakeholder-driven, and this starts with your budgets and your work plans. Obviously, we cannot reach everyone through our engagement efforts, but there are strategies that we can employ. For example, PAC-IUS has trusted community liaisons in many parts of our region in order to build relationships and mutual understanding with our stakeholders and our users and our partners. We saw the benefits of this practice when natural resource managers in American Samoa reached out to us through our local liaison. They wanted to use the sea surface temperature data on one of our wave buoys to inform their field operations to monitor coral bleaching for an upcoming El Nino. But they were grappling with limited bandwidth, which was making even accessing a simple website very challenging. So we worked with them, again through our local liaison, to come up with the best low bandwidth solution that we could. And what we ended up with was an automated daily email to a listserv that had absolutely no graphs and no thumbnails. This is an example of step 2. Design and refine data products with users to accommodate for their unique requirements and styles of interaction. Sometimes a complex platform that integrates multiple data sources, like what a national forecaster might use, is truly necessary. Other times, a simple email is actually more helpful. And finally, how do we ensure that our efforts remain relevant and useful? Since the early 2000s, our colleagues in the Southeast United States have collected user feedback through focus groups, surveys, presentations at maritime community meetings to guide their efforts improving the marine weather portal. This has ensured that their tool continues to address stakeholder needs year after year. Step 3 highlights how this iterative engagement is essential. Needs shift and evolve, as do technologies. New questions surface. We must make the commitment to evolve with them. Product development does not stop when a new tool is launched. Regular evaluation and user feedback are required and necessary to highlight areas for improvement, expansion, or even simplification. In closing, let's celebrate how ocean observing systems have matured to a point that we have begun to really focus on what it looks like to benefit society and how to be stakeholder-driven, all while continuing to be science-based. This is truly a significant achievement and an amazing opportunity for all of us. And there are numerous examples worldwide to draw from of observing systems designing user-driven data products and services with stakeholders to meet specific information needs. Needs like those of a fisherman, a forecaster, a harbor pilot, a natural resource manager. We just need more of that kind of effort. So I encourage all of us to let stakeholders drive, or steer, as it might be, so that we can empower our users with the data and information they need to save lives and protect livelihoods and resources. Mahalo.
Thank you, Melissa. Now we're going to turn to Juliet Hermes, who is a physical oceanographer who models Southern Hemisphere physical circulation and interaction with winds. And she's an assistant professor in the Department of Oceanography at the University of Cape Town. And she's also the manager of the, how do you say it?
South African Environment.
No, the Egagazini node of the South African Environmental Observation Network. Julia.
Thank you. Okay, good afternoon, everyone. Today and during the course of this week, we're going to be working towards developing a sustainable, global, fit-for-purpose ocean observing system. And we know that it's going to involve a lot of sharing of data, of knowledge, technologies, methodologies, infrastructure, and capacity. But it's about a lot more than that. It's about the community. It's about our community. At home, we say it takes a village to raise a child. An entire community of people must interact with children for them to be able to grow and experience a healthy and safe environment. And I think we really need to take that approach with our oceans and with our observing systems. If we look back, as John has done, to Ocean Obs 09, the key impact there was really the prioritization of information. And from that came the framework for ocean observations. And a key thing that that did was to really identify the classes and priorities of information, the societal needs versus the technology's ability to take these much-needed observations. But the FOO requires partnerships between communities to obsess the observation elements for every essential ocean variable, or EOV, and to expand the quality, scope, and relevance of the products. But are the EOVs, and particularly the bio-EOVs, robust enough yet? And do we have methods to measure these EOVs that are agreed upon and adopted globally across the observing system? Opting not to use or document best practices is akin to choosing not to add to the global ocean observing system and putting up a barrier to capacity development and technology transfer. Coming from South Africa and having partnered with American and Dutch scientists to set up a mooring program in the Agulhas Current, which is one of the global ocean's strongest western boundary currents, I can truly speak from experience when I say that human and technical capabilities vary between institutions and also between countries. But it's more than that. The societal needs and the precision requirement for that data also varies between countries. We need to look towards coordinated efforts, such as the Goose IOD Ocean Best Practices System, to ensure access to trustworthy best practices around collecting EOVs and bio-EOVs. If we want to ensure that our observations are interoperable, reproducible, and reliable, and I would encourage, there is a session on best practices on Thursday afternoon at 2 o'clock. So another component of the vision for the next 10 years, as highlighted in the Global Ocean Observing System strategy that John spoke about, 2030, is really about building a comprehensive system, which is based not just on Goose, but on many players, engaging multiple networks in comprehensive observations, including biology. Many of the observations we take are really done to try and understand the impact of environmental change on biology and society. And we're in the cusp of great advancements in the biological monitoring space. But given many of the solutions local, we're in danger of them not leading to global change. But looking at BGC Argo, that's a great example of how with enough knowledge and understanding, we can really get things done. We need to take a transdisciplinary approach with collaboration between those who create information and those who use it. And by doing so, decision makers will be empowered to advocate for the maintenance of Goose using up-to-date information and census results. But this co-design approach really needs to include the modeling community, for they're a critical step in the value chain from data to decisions. They can guide us on gaps in the observations, and they can help us to address uncertainties in the information. Ocean state analysis should really be tightly coordinated observation and modeling partnership, so that Ocean Obs 29 and Ocean Predict 29 meetings will be indistinct. And these meetings don't have to happen more regularly, but we do need to have regular progress reports on how we're doing. And to do this, we need global metrics that are really the best that science can provide. Effective communication and collaboration between scientists from all over the world should not be a thing in the distant future. But the communication should happen not just between scientists. The communication really needs to happen with the ocean and coastal communities. And in this way, we can avoid things such as vandalism to the current observing systems. But we also need to look to increasing the literacy of these communities to the benefits of the system on their everyday lives. Sustained observing requires coordinated, collaborative, and culturally appropriate process which incorporates local knowledge with long-term resourcing that meets identified local, national, and regional needs. And given the influence the observations will have on the economic stability of countries, and also given the rise in the nationalist politics we're experiencing, we really need to make sure that the funding behind this is both international and local. Global networking and coordination should be implemented to minimize regional gaps in all aspects of observing and governance. And perhaps we could look to the Goose 2030 strategy to effectively stitch together a viable patchwork of local, national, and regional systems which are beyond government structure and ensure they're communicating when required. Large marine ecosystems are a really good example of where you have this great transdisciplinary approach, but it's not really integrated into the global ocean observing system. Looking at data, the social impact requires that the investments made in ocean observations are validated by the widest possible use of the data for research, forecasting, analysis, assessments, and application. And that is only possible if the data follows the fair, findable, accessible, interoperable, and reusable principles. And underlying this as well, and if we look to the fourth industrial revolution, where we have AI and the cloud, we're really going to see a huge change in the way we store data and in the way we analyze it. And we really need to make sure that the data managers don't leave behind those that are producing the data. In my final remarks, I want to stay with the theme that ocean observing is not just technology, it is people. It is a community of many cultures and capabilities. We need to strengthen and broaden leadership, so I'm glad Katie asked that question, and a community for sustained observing, and provide the tools for that community to interoperate. This includes best practices, training, and an open and collaborative environment. We need a new, diverse generation of informed ocean scientists where ocean boundaries are not considered, and I was really excited by the event that happened on Sunday with the Early Career Scientists Network. We need to ensure this experience is passed on to the new generations and that opportunities are open to them to lead and to have their voices heard. We need to teach and mentor them in methods we use and how to create the methods that will be for the next generation. So I'll finish up with a Zulu proverb called Ubuntu, meaning I am a person through other people. My humanity is tied to yours. I am what I am because of who we all are. And with that, I would just like to say thank you to the authors of the community white papers, which really informed this talk, and to the people that I've discussed with in the past couple of weeks. I think we've really shared an Ubuntu spirit. Aloha.
Thank you, Juliet. And now we turn to Martin Visbeck, a physical oceanographer who studies ocean dynamics and the ocean's role in climate. He's a professor at Geomar Helmholtz Center for Ocean Research, where he is head of the research group on physical oceanography. And for those of you that haven't had the pleasure of knowing this incredible person who contributes so much to our community, he has been deeply involved in ocean obs through a number of important committees where he serves co-chair of the scientific steering group of WCRP CLIVAR, officer of the Joint Scientific Committee of WCRP, and now a member of the executive planning group of the UN Decade. Martin.
Well, thank you, Margaret. And again, I'm standing in here really for Jillian, and this looks interesting. That is not my slides. So I guess I don't know what we're going to do now. These are Jillian's slides, and I send a different slide set to the organizers. I guess I'll make do with hers. I added a few dimensions there. So Jillian comes from the United Nations Environment Program, and we asked her to be here on this panel with us because we were really trying to understand from a UNEP perspective what ocean observations can do, how they can support the work that UNEP does. And again, as we heard this afternoon already, in this sort of stakeholder interaction process, learning from our customers, learning from our users, how we can be more efficient and in some sense more fit for purpose. So we'll see if my slides show up, but let me just give you a few backdrops there. When you look at the global scale, ocean observing is informing global issues, things like climate. When you look at the regional scale, we heard some elements just in Julia Hermit's talk about major current systems, say the Angara system, the Benguela upwelling system, so these are more regional challenges. Then we had a talk about Hawaii and what you do with your stakeholders here, which is much more local. And when you are a policymaker, quite often you have to bridge all these scales, right? So it's an interesting challenge for an ocean observing community to, on the one hand, make sure that what we do connects up at the global scale, but on the other hand, is also relevant at the local scale. And I think when you work at the United Nations Environment Program, you are in the same sort of boat. What they're doing is they have regional groupings, they have global aspirations, they have also local issues to solve. At the local level, I think we heard comments about best practice, and best practice is something that you do around the world, so it's globally shared, but it's applied locally. And it's one of the mechanisms that allows you to make sure that what we do at the local level scales up to the region and can also be done at the global level. So that's one element of it. Another element is when you do global policies, for example, at the United Nations, sometimes you have to report on progress that you do. For example, the 2030 Agenda on Sustainable Development has a number of targets. Very few of them are around ocean. So I worked with the UN and tried to suggest some targets and some indicators that would allow you to monitor progress against the targets. And all the indicators that I suggested, Margaret, were rejected. And they were rejected not because the academic community couldn't deliver on them, even at the national level, but they were rejected because the condition is that the National Statistics Department has to be able to submit that number. So if you have a global satellite map, let's say of primary productivity, that is not an acceptable metric, although it is global, and you can parse it up to each EEZ of each country. So unless that country has the ability to report that data through the system, it's not an acceptable indicator at the UN level. So I guess we from the academic community didn't consult with our users enough to understand that that map is great for us, but it's not helping them in delivering on their policies. So I think that's one of the interactions I think that Julian in her slides are saying. The other level, which is interesting, is one that I also heard, Juliet, you were remarking on. In some ways, we are observing data points. That's important, and we have to make sure that they get used and reused and put in data repositories. But when you scale them up to information, there's more you have to do. You have to look at the data, you can fuse the data of different sources, you take some other knowledge into the process, and then you come up with what we call information. So it's a process that goes one step beyond. And I think this morning's panel made a lot of points about the information we need about the ocean. And I think it's the connection between the data and the information that is exciting. At UNEP, they do that a lot, because they have to deliver information on the health of the ocean, on pollution issues. And again, it's the connectivity from data points and other concerns that you might have that connects to policy. The last point I think Jillian was trying to make to our community is how do we sort of make that information that we have available to a much broader base? And is ocean so special and so different than in other areas of environment? And I think her conclusions were maybe not. Because when you do environmental problems in general, you have lots of different experts community who have some information on their issue. But quite often when you want to talk about the status of the ocean, the health of the ocean, the health of the environment, you need to be able to connect these things up. So what it means for us in Ocean Ops community, quite often we have data on the physics, on the chemistry, ecology, biodiversity, maybe seabed in different communities, in different data sets, with maybe best practices in that community, but they're not always commuting well across the board. So the remark that she was making, it's very critical for us in the observing community to connect these data sets, to understand each other's challenges, and see what from our perspective, say for the physics, the chemist, the biology, ecology, from the socioeconomics, how we can bring these data together against these policy issues. And I think these are requirements which are coming more towards the ocean ops community at this meeting and for the next decade than we had in the last couple of decades. So we're broadening up our stakeholder community from the scientists who were driving Ocean Ops 99, scientists on a bit broader scale in 09, but now we're hearing many other users of that same information. And that means we have to be a bit more professional about it. We have to understand better what their questions are, what we can contribute to that, and we paraphrase that under this logo, fit for purpose. And the fit for purpose from the UNEP point of view is that we make our information available such that, for example, statistics department can report on them. For example, environmental agencies can use the information in addition to what the scientists can do. So I'm going to stop here. I'm sorry you didn't get the slides, but I think I sort of made do. And I'm happy to take any questions. And it's a bit sad that Gillian couldn't be here, so I hope I could fill in a little bit and give you the sentiment from that UN perspective, the global reporting, that they have special desirements on us, the ocean observing community. Thank you.
Thank you, Martin. Pretty good for no slides. It's the message that counts, yes. Now, a special treat for me, a person that I've worked with in my career for, we won't say how many years.
4 years.
4 years. Thank you, Ako. Geophysicist and geological oceanographer who studies the tectonics and sedimentation in the Western Pacific subduction zones, back arc basins, fore arc basins, former professor at University of Tokyo Ocean Research Institute, and now the president of JAMSTEC, the Japan Agency for Marine Earth Science and Technology. Asahiko Taira.
Thank you, Margaret. As she explained, I'm a geologist, so I have a different kind of background from most of the community here. But I like to take a look at the ocean observation in different or more broad scientific perspective. The science emerging at this moment very, very rapidly. So my title is Integrating Ocean Observation with a broad framework of human, earth, planetary science and technology. So I borrowed this slide from my colleague Sanae Chiba-san, and this explains the last 20 years of the evolution of the ocean observation. The main progress of the observation was understanding the role of the ocean in the system and providing information useful for sustainable development and blue economic growth of our society. The main progress of ocean observation has been toward coordinating observation system to deliver ocean information, thus promoting integration of global observing and data system, and ensuring the interoperability of enhanced value chains of ocean observation. There is no doubt that the ocean observation played a key role in the progress of the ocean Earth system understanding and sustainable science and technology for our society last 20 years. But the last 20 years have also witnessed major progress in the science related to our system, but came from a different point of view. One is the frontier research in geobiology and astrobiology, and the other is search for exoplanets. Geobiology here defines the biota study of organisms which closely related to the geological processes like subsurface microbiosphere. And exoplanet is an extra solar system, planetary system, which found outside of our sun solar system. These essentially end up the progress of habitability science and technology, So for example, I'd like to show something happening. One is the finding of the deep biosphere underneath the ocean floor to the 3 kilometer in oceanic crust and sedimentary layer. And publication 20 years ago was 20, and now about 120 publications per year. Exoplanet solar system, which is beyond our our own solar system, is extraordinary. 20 years ago, there was 20, but now over 4,000 exoplanets being found. Last 20 years also see the extraordinary progress related to the genome editing, engineering, or deep learning, artificial intelligence, some called directed evolution, and manipulating the ecology. These lead to the transformation of a human body and life itself, and transformation of our society and environment, which eventually led to the new human science and technology. Like synthetic biology, which created a brand new, completely manipulated artificial cell, or the CRISPR-Cas9 editing of the human genome eventually led to the very, very controversial first birth of genome-edited human body. So I like to summarize. I point out here the 4 layers of the science, the Earth system science, and sustainability science. These are the ones which ocean observations have been mostly related. But present day finding of the deep biosphere and astrobiology have led to the new kind of science called habitability science, understanding the origin, evolution of life, all these things in the total package as a habitability science. And the human science have a new generation, new era, because as visionary author says, human being will be no more same as present humans in next 10, 20, 30 years. So there is a connection from the ocean observation, being the role of the ocean is important in the habitability science and technology, understanding of planet habitability. Also the human science, change our society, change our human body, transformation of our body itself has sort of time scale, 10, 20, 30 years. So this observation and human ocean observation and human science has sort of time scale connection in the sense. So broadly speaking, I say that the ocean observation is closely related to 2 areas, new human science and habitability science. I believe because of this connection, ocean observation and its community should expand its scope of visions in the future. We need to dispatch a new visionary perspective on the future state of the planet, our society, and our physical existence itself. Thank you very much.
Thank you for that big vision, Akko, and stretching us into some fields that we aren't talking about here today. So we only have a limited amount of time before your break, so I'm going to go right to the Slido questions. And let's see what... So this first one sort of echoes questions that we had in the last session about coastal observing. Let me turn this around, not to what scientific parameters we we need or what kinds of questions, but turn to those of you who have spoken so eloquently about the user community. What are the questions that the user community wants us to answer for the coastal zone?
So I've heard a few people today talk about the state of coral reefs in the world. When you look at the health of coral reef indices, barring a few exceptions, there is actually very little data that tells us about the long-term health of coral reefs. I think David Abura is in the audience somewhere. The Global Coral Reef Monitoring Network was set up many years ago and has been in senescence, really, in many ways, and I think really has had a rebirth, largely because we've lost half of the coral reefs of the world in the last few years. We now know how important coral reefs are. It's a coastal system that is absolutely essential for livelihoods and a whole range of other things. And yet we have not systematically thought about how we'll do it and then maintained an observing base for that. Now we could talk about macroalgae, we could talk about a whole range of systems that are fundamental communities to the health of coastal systems, and again, we are not systematically monitoring those. So my sense is the questions are partly just as health indices because people care, and partly because, in fact, if we see collapses of those systems suddenly, as we have now in coral, everybody's going, well, what does that mean for us? What can we do to reverse that decline? So my sense is that we have many, many societal and economic reasons why we should be doing it.
Melissa?
I would just add that for the Pacific Islands, especially, which is my area of knowledge, stakeholders and users are asking for more information on how to plan for sea level rise, as well as the short-term impacts of inundation, whether that be from storm surge or swell events just on top of high sea levels. That's, for us, one of the most important parameters that people want to know about.
So I come from Germany, which has a very small coastline, but in the Baltic Sea, just like in some other parts of the world, like in Hawaii, when you support tourism, you're very interested in the ocean health and both sides of the health. One of the healthy ecosystem, coral reefs were mentioned because that draws many tourists to the beaches, to the water, but also figuratively because if the water is not safe, if there's harmful algae blooms, it's also advisable not to go swimming. So there's another question around that as well. And lately, I have a lot of friends that work and live off the coast in the Caribbean islands. And if you just think about what's happening right now with sargassum, which is destroying whole tourism industries. So you can see that the environmental status of the coastal systems in many dimensions that were discussed here are driving, I think, observing needs, and in particular from some of these issues that you mentioned, inundation, and I'm mentioning here the harmful algae bloom or blooms of algae in general, are also relevant to decision makers. If you can forecast them 2 weeks, 4 weeks ahead of time, you can plan mitigation efforts for that, and that could be to get people out of harm's way, but it will also be to have other interventions that you want to plan for. So I think there's quite a number of different reasons why to build up a coastal observing and prediction system, and it will be location specific.
Other comments? Let's look at the questions again. Okay, transparency. And it's really the question of how do we provide incentives for other communities, whether it's military or industrial interests, in adding to our data stores. Any comments on that? We recently were at, several of us were at a meeting in Denmark where we talked about this, and one of the speakers said that he thought we needed some more incentives for data philanthropy. in other words, the contribution of your data to the open system. And I think that it sort of goes hand in hand with also the issue of incentives for people, for scientists or nations to put their data in. Sometimes it's a problem of just the sheer intractability of trying to get it into the system. We need to work on that, and sometimes it has to do with concern about how the data would be used in a way that would compromise national economic interests. Yes, Juliet.
My comment would be not so much about the data transparency in the military, but coming from South Africa or from a developing country where you get a lot of programs who are interested in our coastlines and our shelf seas and our oceans, and it would come down to co-designing from the beginning. So we have a lot of international people who want to come and maybe observe the Agulhas or the Benguela, and I know it happens in other countries as well, and they will come and they will do their research and then they'll leave. And the data isn't perhaps shared, or you're invited at the end, oh, well, we'll put your name on our paper. But really, it's about the co-design of those projects involving people in those countries from the beginning as much as possible to try and share that data and allow countries to have access to it.
Great point. Ako.
A little bit different perspective. That there was a discussion of coastline observation is important because of sea level change and so forth. Also, there was pointed out that the coastlines are forecast to be a major change in oceanographic point of view. At the same time, mega cities like New York, Los Angeles, Tokyo, whatever, that is a change site of the major transformation of human being and biotechnology is action is going on. So I like to see observation directly related to the mega city down to the deep ocean in a way as more standard way of observing next 30 years or so of the interaction between human population and ocean itself, and even connected to the seafloor actions, whatever Larry may have been talking about.
I want to make sure that you have a break before this really interesting event that's going to be at 4 o'clock. So I think we'll stop here. I'll just say that my take-home message from this panel is for those of us who are observers, it's not just about us anymore.
Thank you all. We'll reconvene at about 5 minutes past 4. When you see the paddle outside, it's time to come in. Remember that if you're leaving, and you're going to miss a lot this evening and later this afternoon, but at 8:30 tomorrow morning in here, you'll get a bit of a recap and your guide to the rest of the conference. So it's important the first hour of the day. Have fun out there.